In math today, we're going to start on Seesaw. Please click on Activities. Click Assign to Class folder. Blue, Math. And our task is called What Makes a Good Scale? We know we've been learning all about graphs. Yesterday was our first day that we started to make a graph using data. So today we need to learn a little bit more about how do you choose the scale? If we're not counting by ones, how do you decide? Are we counting by twos? Are we counting by threes? Should we count by fives or tens? Today, Miss Sharp is going to help us understand a better way. How can we choose an appropriate scale? Yesterday in our lesson, we talked about how your scale needs to go up bigger than your highest data point. That way, all of your data can fit on the graph. That makes sense, but still, it's tricky to know, how do I pick a scale? How do I choose how to skip count? So let's go ahead and open up our work, please. And we are going to begin by listening to Ms. Sharp talk about our success criteria.
Today we'll be continuing with creating scaled picture graphs, scaled bar graphs, and frequency tables to represent a data set. Yesterday we started creating our graphs using a frequency table to represent our data. Today we're going to be really looking at that scale and making sure that we have a scale for our bar graphs, picture graphs, and line plots that makes sense. So again, our guiding question is today is going to be, does our scale make sense?
Okay, yesterday in our lesson, I gave an example about why in third grade we don't want to count by ones. Why do we not want to have a scale that counts by ones in third grade? Why would we make that rule, Landon?
Because we're third graders and because it's harder and slower. If you count by fives or tens, it's gonna be faster and easier.
Absolutely. So one, the reason is because it's a third grade skill, right? The real reason is if you count by ones, it's going to take forever, right? It's going to take forever. So Landon gave an example. If you count by fives or something like that, you can skip count faster. You can show the data in a more easier way. Okay. I saw some other friends wanted to share out that same thing. Thank you so much for being willing. Gloria, you have something new to add. Say it again, Gloria. Right. Sometimes our graph isn't even big enough. If you count by ones, it might be going way up here. If you have like 30 votes for chocolate milk, that's 30 things, right? We don't need that much. So in third grade, we learned we can skip count. Nick? Oh, you're just showing us how high it would go. Exactly. That's why we want to make sure we have a scale that makes sense. Counting by ones does not make sense in third grade because our data is so much bigger. It doesn't make sense. Here is an example. This is our first example. Ms. Sharp is going to show us how she came up with the graph and the scale. I'm going to push play on the video and I want you thinking about her example. Listening means your eyes, your ears, your body is focusing your attention and you're thinking about what the speaker is saying. Here we go.
Today we are going to be using a frequency tally chart to complete a scaled bar graph, pictograph, and line plot. I'm going to start today with our bar graph, and we're going to focus today on determining what is the best scale to count by for my bar graph to make it easier to interpret the data answer questions and analyze the results. We're looking at Steve's class. They voted for their favorite snack. Steve made a tally chart of the results. We've got popcorn, fruit pops, and yogurt. The first thing I'm going to do here is I'm going to count up each category and write the total. We've got tally marks here, so this is a group of 5, 6. For fruit pops, we've got 5, 6, 7, 8. And for fruits yogurt, we've got 5. So here I can see that I've got 2 even numbers and an odd number. We've got groups of 5 here. So, I might think, oh, let's count by 5s for my scale. And that might make a really quick graph. So I'm going to come here and remember, we've got our categories across the bottom, popcorn, fruit pops, and yogurt. We've got our title. We've got the place for our scale and numbers on the side. And right here, I said I'm going to do a scale of 5. As I make my chart, my bottom number, the one right here, is always going to be a 0. Remember, our graphs always start at 0. And I'm going to count by my scale, which is 5. So I've got 0, 5, 10, 15, 20, 25. So for popcorn, my total was 6. So I am going to color in that much. So I will color for popcorn. Let's make it kind of match that blue. So I'm going to start at 0. I'm going to go up to 5. And then 6 is 1 more than that. Well, I don't want to go up to 10. Halfway between 5, because see, there's another line here. So halfway between 5, 5, 6, 7, 8, 9. Well, that doesn't make as much sense. I'm really struggling with that. If I put it just like a little bit above here, which I think it might be, I hope whoever reads this graph would be able to figure it out. Let's keep going and see if the rest is easier. Fruit Pops had 8, so I can go, it's not up to, all the way up to 10, but it's up to 5. 5, 6, 7, 8, 9, 10. So somewhere in here, I know that 8 is closer to 10 than it is to 5. So I'm going to go a little bit over halfway. Oh, I hope my person can read this chart. And now for yogurt, well, that's going to be an easy one. That one works out nicely because it's 5. So my reader will be able to understand this chart because it stops right at the line. But I'm not sure they'd be able to answer how many more and how many less because this chart is not very clear. If we covered up this graph, this frequency chart over here, and my reader could not see what the answers were, they might struggle here to find out and figure out how many people chose popcorn and how many people chose fruit pops. So it might be hard for them to answer how many more people chose fruit pops than popcorn. I might need to come up with a different scale. Look at the next slide and watch a different example.
Okay, so Ms. Sharp did a really good job modeling what a lot of us are probably thinking. When we see a frequency table with groups of 5, immediately I think, oh, this is great. I'm going to count by 5s. But then you can see how it worked out. You can see how that when she started counting by 5s, because of her numbers, because of 6 and 8, it was a little bit hard to read. The popcorn bar, I didn't know if it was at 6 or 7. The Fruit Pops, I don't know if it was at 7, 8, or 9. It wasn't very clear. It wasn't accurate. Miss Sharp did the best she could using her scale, but I'm thinking that scale was not appropriate. I'm thinking counting by 5s left too much space between each number, where she kind of had to guess where to stop her bar. And then when we're looking at the graph, we kind of have to guess. If you asked me how many kids ate Fruit Pops, I might say 8, I might say 9, I don't really know. And that's the problem. When you create a graph, it needs to be so clear that everybody looks at it and they say, I can see it stops right here. 6 kids voted for popcorn. So in the next example, let's see how Miss Sharp does it again, but this time she's going to pick a scale that works, a scale that helps us understand and be able to read the graph. Here's her second example, and Honesty's already predicting. If we're not going to count by 5s, maybe count by, let's try counting by 2s. If we count by 2s, it might be easier for us to read the graph and easier to make the graph. Let's see if she chooses to count by 2s.
After watching the previous slide, you can see that my scale that I first chose was not the best choice to be able to analyze the bar graph. So I'm going to choose a different scale. I remember that my popcorn was 6, Fruit Pops was 8, and yogurt is 5. All of my numbers, they're pretty small. They are under 10. I know that I can skip count by 2s, 3s, 4s, 5s, 6s if I wanted to, but an easy one, when I have this much space and all under 10, I'm going to try skip counting with a scale of 2 this time, because I can easily count by 2, 2, 4, 6, 8. To make my bar graph, remember, our bottom line is always 0. Always going to be 0. And then I'm going to go 2, 4, 6, 8, and 10. So I am counting every other line here. As you can see, there's a line in between to help understand the data. So for popcorn, I see that I have 6. So I'm going to color in my popcorn all the way up from 0 to 6. For my Fruit Pops, you see that I have a total of 8 people that liked Fruit Pops the best. So I'm going to start at 0, 2, 4, 6, 8. And color that bar in. And then my last one is my yogurt. And you can see that 5 people liked yogurt. So I'm going to count up here, start at 0, 2, 4. I'm not going to go all the way up to 6. I'm only going to go up halfway to 6, which is 5. You can see here that this is right at 6 for popcorn. Fruit Pops goes up to 8. And yogurt is here halfway between 4 and 6, which is 5. So now my readers, unlike the previous scale of 5, they will be able to answer how many more people like Fruit Pops than popcorn. They can very easily determine how many people like Fruit Pops and popcorn to be able to solve this problem. So I am good at keeping my scale of 2 classmates.
All right. So Miss Sharp did a really good job showing us 2 examples. skip counting by fives did not work out so great. But when she changed her scale to skip count by 2, she realized that was a lot easier because there's not as much space between 2 and 4 than 5 and 10. There's a lot more numbers in there. So today we're going to practice this skill. We are going to work on selecting an appropriate scale. Go ahead and join me on slide number 6, please. Click on slide number 6. And we are going to use the same frequency table that Miss Sharp has been using, but we're now going to show a picture graph. She modeled a bar graph. We are going to build a picture graph. So our same data is over here. Steve's class voted for their favorite snack. Steve made a tally chart of the results. 6 students said popcorn. 8 students said fruit pops. And 5 students said yogurt. Take a look at our picture scale, at our picture graph. The same categories are listed on the picture graph. I noticed that we do have a title. It's way up here. Our title is up here. When you make a graph, you need to make sure that you have a title and that you have the same categories. It should match. Whatever's on your frequency table should be on your graph. You're supposed to match them, but show the data in a different way. Okay, here we go. Let's start talking about how we're going to show the data. Down here, Miss Sharp has given us a student and a half. Take a look at that. These are the picture symbols we're going to use to make our graph. So if we have a student and a half, what type of scale would be appropriate to use? Think about Miss Sharp's examples. We tried counting by fives. That didn't really work. Then she counted by what, Angela? She counted by twos. So Kaylee, if we used these symbols, how could we show which one means 2? What does the other one mean? What could we do? So the half one equals 2 and the whole one equals 4, kids? Yeah. Okay, so remember when Miss Sharp counted by fives, it was really hard to read. So can we show 6 if we have 4 and 2? Can we show 8 and 5? How could we show 5 if one kid was 4?
I know.
If we had one kid that was 4, and then we had half of a kid that's 2, that equals 6. How can we show 5? I don't know if counting by 4s and 2s is the best scale because we have 5. 4 plus 2 is 6. So we can't even show 5 on our graph. We have to make our scale smaller. What can we do, Dave?
It's 3 and 2.
So remember, if you're gonna have half of a picture right here,
The half is a 2 and the other 3.
but if you're showing, if the whole person is 3, half of the picture needs to be half of 3. What is half of 3? Uh-oh, that gets really messy to cut 3 in half. That gets really messy. I think our scale needs to be even smaller. Theo, what are you thinking?
So the whole one is 2 and the half one is 1.
Okay, so let's try that. The whole person equals 2, and then the half person equals 1 vote. Okay, and this makes sense because Miss Sharp used this data already, and she had success counting by 2s. So I'm guessing we can have the same success counting by 2s and 1s. So our scale is a whole symbol is 2, and the half is 1. The whole person means 2 students. The half student means 1 student.
And then
Bless you.
if you get 2 students and plus 1 to half of it, 5.
Right. So Honesty's already predicting, can we show 5 using this? The answer is yes. Okay, remember yesterday we duplicated our people, our pictures, just like that, and then you can move it. So let's show popcorn. Popcorn. Kaylee, how many students voted for popcorn? Was that Kaylee who said that? Okay, 6. So we're going to skip count by 2. So 2, duplicate, 4, duplicate, 6. If each whole person equals 2 students or classmates, we can skip count by 2s. 2, 4, 6 students chose popcorn. You may copy on your graph, show the same thing. Copy and paste them or duplicate them and show your popcorn results.
So whole classmate equals 2.
Okay, Maberly, how many students said Fruit Pops were their favorite snack? Dave, please be respectful. Thank you. 8, so we're gonna skip count by 2s up to 8. 2, 4, 6, 8. I'm noticing that popcorn and Fruit Pops are both even numbers. 6 and 8 are even numbers, which is why it's making it so nice to skip count by 2. Even numbers make it easy to skip count by 2, but 5 is an odd number. Our last data point, 5, is an odd number. That's why we need that half. We can't skip count by 2s and get to 5. We need a half. So 5 students said yogurt. So 2, 4. If I added a whole new person, that would be 6, and that's not accurate. So I cannot do that, right? We need our half, which is equal to 1. Now when we count yogurt, it's 2, 4. Now we have 5 students who said yogurt. Today, you are thinking about an appropriate scale. How can you show data accurately and clearly? Remember our scale of counting by 5s? It was pretty hard to read. It would be hard to answer questions using that scale. That would be too tricky. Great job working on your picture graph on slide number 6. I want you to move to slide number 7. I want you to show the same data, but this time on a line plot. If Miss Sharp counted by 2s, and we counted by 2s, what do you think each X could equal?
2.
I think it's fair to say X could be equal to 2. Remember, sometimes line plots show each X as 1. Sometimes we see a scale where it says each X is equal to something else. You have to read the graph to understand it. I want you to take 1 minute and show your X's on the scale for each section. Then we will share out. You have 2 minutes to build your line plot using your scale of 2. All right, our last job is to check our line plot. Remember, sometimes X is equal to 1. We have seen some graphs where that is true, but today we're practicing where the scale is not 1. So an easy scale to use is when X equals 2 classmates. We can count by 2s, and then we have to show a half, just like we've been doing. So for popcorn, if each X equals 2, you should have 3 X's. 2, 4, 6. Your data on the graph should match your data in your frequency table or your frequency chart. If each X equals 2, you can skip count by 2s to get there. Fruit Pops, you should have 2, 4, 6, 8. If each X equals 2 people, you should have 4 X's because there are 8 students who voted for Fruit Pops. Where it gets tricky is yogurt, and I saw lots of different strategies of how you figured this out. Yogurt has 5 students who voted for it. We know we can't skip count and equal up to 5. We could do 4, 2, 4. But if we make another X, that is 6. Have a seat, please. If we do another X, that's 6. We cannot do that. I saw friends who did half of an X, like this. I saw friends who wrote something like half. I saw people who did half of an X, like that. Really good job thinking about a way that you can show that 1, which will be equal to 5. I'm going to do this. That's my strategy for today. Yes, Angela.
I did that same game.
Perfect.
2 X's.
Perfect. 2, 4 plus 1 is 5. Your task this afternoon starts on slide number 8. You have a bar graph with a frequency table. You need to choose the scale and write the scale. Then you will show the data on the bar graph. On slide 10, you have the same frequency table, but this time showing a picture graph. On slide 11, you have the same frequency table, but this time showing a line plot. Just like we practiced this morning, you're going to practice this afternoon, choosing an appropriate scale and creating your graph to show the data from the frequency table. Okay, that is all we have time for today. I will be on at 12:45. If students have questions about their task, it's now your lunch and recess. Then this afternoon, you need to finish all of the math slides. I will see you at 12:45 if you have questions.